Welcome to my talk about Upstream embedded Linux on RISC-V. And basically, that's about me. I joined CodeSync last year and working there on embedded Linux stuff now. The Banana Pi F3, that's this board here. I will also demo it at the end. So it's an industrial-grade RISC-V platform. It has this SpacemiT K1 8-core SoC. It's quite powerful. I would say from the cheaper SBCs, it's probably the most powerful right now. It is available with 248 or 16 gig of RAM. With eMMC on board. It has 2 gigabit Ethernet, which is kind of nice for industrial use, 4 USB 3.0. Also has PCI Express, and it has, for graphics, it has a HDMI output, dual CSI, and like I said, it starts, I mean, that's like the 2 gig version starts at like $60. AliExpress or wherever you source your stuff. Okay, when you get that, then of course at the beginning, there is not too much around, so the vendor has some stuff. I looked at that. The latest version is 2.04. It got released in December. That one also works now really with the 16 gig version as well. And for testing, I used here this image. You can boot it from a SD card, and downstream sources are available. There is some stuff from the chip vendor on Gitty, as well as from Banana Pi. They have a GitHub account. It's this Xenovoip stuff. They use an old OpenSPI version 1.3 and U-boot 2022-10, Linux kernel 6.6.63, and the rest of the user space is based on Ubuntu 24.04, and they also provide some APT source, so you can actually also update your stuff. And other features is GCC 14.2 based or LLVM 18.8.1, and for the graphics they use Mesa 24.01. But yeah, ugly Chinese vendor downstream stuff. Then toolchain. It was actually the first time I went into the RISC-V space, so I was only familiar with ARM so far, so I had to find out where you get your toolchain. And there is this RISC-V collaboration thing on GitHub, the RISC-V collab, and they provide kind of convenient for me as a x86 user, even though I could now put a RISC-V motherboard in my framework. Woo! But right now I'm on some Ryzen stuff, so there they have pre-built tool chains that work fairly well for me. The latest one available as of January 20 is GCC 14.2.0 or LLVM 19.1.7. Also on that GitHub page you find guidance, if you want to build your own tool chain for major Linux distros with all the dependencies and stuff you would need, or also for Mac OS with their whatever brew thing they use. I'm not much Mac OS guy, so I don't know, but you could probably easily find out there. Blended, then I was looking at Upstream U-boot on that board. Initial support actually just got merged before Christmas on December 18. It's this git hash here, and It also has some documentation, however, that they talk about using downstream OpenSPI from that vendor GitHub stuff. I asked the guy about that and whatever, but I then tried it with just upstream OpenSPI, and for me it worked just fine. So it's confirmed working. And in flight as of January 20, there is a 5th version of a patch set that also probes the DRAM, because that was my other question to the initial patch, that it hard-coded the RAM size, but I have different of those boards with different RAM sizes, not. And now, tada, there is on the mailing list version 5 that auto-detects that. Basically just reads from the RAM controller what configuration it is, and then does it automatically. What else is to do? So far the SPL support is missing, so in that same documentation they write how you basically just have to use the Chinese Super Trooper thing, and you leave the SPL from that vendor downstream stuff, and you only replace U-boot proper node. So for now, nobody looked into the SPL stuff. So it relies on the vendor one. And then, of course, the next stuff would be to add more missing peripheral drivers. That right now, that U-boot is not much useful. Not it's just like a console, serial console. That's it. It doesn't support any kind of peripherals, storage or anything. But yeah, at least so far so good. That is. Sorry, don't know what happened. Can you still hear me? Okay. That is how that looks. So you see on the left side, that's basically the SPL output is from that SpacemiT downstream stuff, and then it spawns U-boot proper, which is latest upstream. Also with that DRAM patch applied, as it shows here, the 16 gig that this board has. Okay, then let's have a look at the kernel. Upstream kernel. Initial support actually just got merged on January 17. However, as you guys probably know how that works, it's only in -next so far. So it's targeting to be released in 6.14. And the pieces that are there is a device tree, pin control, and also the console UART. Then there are another bunch of patches in flight right now. As of January 20, there is version 4 of GPIO support, which I also gave it a spin. That one, they used the heartbeat LED to blink that node, so you can pretty nicely see whether that is working or not. Then they also have a patch set version 4 of the clock controller support. That one I applied, however, you would kind of now need also peripheral drivers that then use that node, so I'm not so sure whether it does much without any of that. But yeah, it built and kind of is there now. Then another driver that just recently got posted, but first version is for the PEMIC. They call that the P1 PEMIC. It's also from the SpacemiT company. They also do the PEMIC for it. And that patch set, you see it there on the to-do, that one didn't even build for me. I think it's missing some other glue pieces, who knows. But for now, that one, I haven't seen that working. But another one I have seen working is a version 4 patch of the I2C support. However, that would be a peripheral driver, but it doesn't use the clock yet. So I think it relies probably on the bootloader having enabled that clock or something like that, because it magically works, but it doesn't talk to the clock. So I also had to hand tweak that. It was missing all the device tree parts, which is kind of, as if you have ever worked with that stuff, it's sometimes a little bit tricky, especially in the downstream. They have a total different way that they arrange this whole stuff, also with the interrupts, because there are different interrupt controllers and all these kind of details. But I hand tweaked that, and the good thing is, and I also list that in the references, I mean, SpacemiT has fairly good reference stuff on the internet available. However, which I find a little bit inconvenient, you cannot just like download it as a PDF or something like that. They just have this website that has all the reference manual and stuff, and you kind of browse through that. But it really is there, and you can find out what interrupts and addresses. And so I was able to kind of construct the device tree. At least, I mean, I think it has like a dozen channels, I2C, and I only concentrated on one of them, which has an EEPROM on it, and I was able to poke the EEPROM. So that driver also seems to be fine. And then, of course, other stuff would be more peripheral drivers to be more useful. Not too bad. That is how that looks. In this case, I actually use, as I said, you can't really use Upstream U-boot because that one doesn't really have any peripheral driver where you can load anything else. So I had to use downstream U-boot to run Upstream Linux. And when you use the vendor stuff, you get in the environment, you get all this detect DTP and all this kind of stuff. But of course, it doesn't work with the defaults that downstream uses to boot downstream Linux. And I just used this, basically set the boot args just to the console, that you actually also get some output, and then I used whatever downstream RAM disk in this case and boot it like that, because remember, the kernel doesn't have any further peripheral drivers, so at least I get then the RAM disk and can poke with that you see here, init RAM-fs, and there even that init RAM-fs conveniently has the I2C transfer thing contained, which was kind of cool, so I was able to test whether that I2C stuff I hacked together actually really works, and you see that here. Okay. Then let's have a look at more like build systems and complete kind of distros then, not one that is much used within CodeSync is basically FreeDesktopSDKs. We are the guys that are, I guess, the main supporters of it. FreeDesktopSDK as a build system, it uses BuildStream, BuildBox. It might not be that known to most guys. It's basically, they only do native compilation. That was, of course, a little bit problem, so they don't do cross-compilation. So I then tried with QEMU, user mode emulation. That is also known as QEMU user static. And that actually works amazingly well, but of course it is really slow. And compiling like that, the kernel took like way overnight, And I mean, it kind of works, but it's not very convenient, So I went to Javier and told him, well, give me the money, and we have that, Luckily, we have nice Milk 5 Pioneer machines. They have this Sophon 64 core, plenty of RAM and stuff, and they're really fast. And on that machine, it works just fine to build that stuff. Yeah, as you have seen, Ben also talked about RISC-V stuff. We are quite a frequent contributor in that space. And FreedesktopSDK on this board is a work in progress. Basically, there have been two of my colleagues, Tom Rodriguez and Matteo Martelli, working on it. And there is now a merge request. I have it also listed in the references if you are interested. It has, I list here the build stream elements to build that. Not basically we have a component OpenSPI for the SpacemiT K1 that basically builds the downstream OpenSPI. Then we have a U-boot element that builds the downstream U-boot, and we have a Linux kernel element. Usually, of course, FreedesktopSDK would use. That's not good. FreedesktopSDK would use a somewhat upstream kernel, but in this case we cannot do that, so we have to use a separate element to build the downstream kernel node. And then basically that has to do with the way this board boots. It needs its boot chain in a certain way. I mean, the boot ROM expects it that way. For that, there is a VM firmware bootloader SpacemiT K1 element that basically uses GenImage to generate the disk image of those above pieces. Plus, there is like on the very first block on the SD card, it expects so-called boot info. From that, it determines all the other pieces and stuff like that. That's just some kind of a 80-byte boot info header. And then as user space, one can use regular RISC-V user space, for example, VM minimal FE. And that GenImage generates a disk image which includes FE and whatever other pieces. We have to do more testing and iron out the remaining issues. Like I said, thanks to my colleagues who contributed that stuff. And you can find the merge request in the references, and there is, of course, discussion going on about some details there. That is FreedesktopSDK, how that works with build stream, so the BST command, basically like bitbake for those guys that know that, and then you specify with downstream BSP, you specify the SpacemiT _K1, and then you can say I want to build this bootloader element, and that of course builds all the dependencies and all that stuff. And then once you have built it, you can check out the artifacts. That's how it can be done. You give it a directory and it puts the stuff there. The same can be done with heavy stuff. And that is then, I list here. Also you see how the sizes are of these parts, and basically bootloader, there are two variants that Matteo did. One for the SD card, where it just gives you a disk image that you can basically DD to your SD card, or not DD, to DD or not to DD, that you can join my talk tomorrow, I would not DD it, but I still casually talk about DDing, Maybe I should change that language as well. Anyway, And for the NOR, you have to then basically upload these single pieces on your own. But he talks about that in the merge request. It's documented, not. I left that for reference there. And same disk image for the EFI stuff. Okay. Then Yocto Project. There is a Meta RISC-V on GitHub, not that you guys are probably familiar with. I also, to get more into the RISC-V topic, I also have some other of the, general available boards like the Milk-V Duo or the Vision 5.2, and all those are, for example, supported as machines in the Meta RISC-V. And yeah, it's a general hardware-specific BSP overlay for RISC-V based devices. And in July there was actually an inquiry as an issue on that GitHub that somebody asked about BPI F3 support. And yeah, but so far that's the only thing I found anywhere. There was no progress ever since. Not. So to do is basically everything, ugly or not, but it's just a little bit of work. So I've started working on a machine configuration. It's a conf machine, Banana Pi BPI F3, and then yeah, a recipe for the bootloader that builds the downstream U-boot, and then a recipe for the Linux kernel. There, the only thing that I had to do is I had to disable some failing stuff. I guess the way Yocto builds the kernel, it somehow tried to build some stuff that doesn't build in this super ugly downstream stuff. Not so. But with that, it basically works. And then, of course, it needs a wiki image that puts all these parts together and also adds this 80-byte boot info thing. And that is basically where I'm still working on right now. And then I need to do some more testing and ironing out some remaining issues. And I put in the references a link to my GitHub, and I will put this current status of the stuff there, and you can check there. And I also plan to then submit it now. Okay, very good. Then we have some time for the live demo, which I brought here. That is more or less what we have here. Let's see how we do that. I have here a terminal. Can increase the font a little bit. So that basically I have here an FTDI thing that just does the console, not. And I steal the power here. It can actually be powered either by good old 12-volt barrel or by USB-C. And I just use a USB-C here. Let's see. Somehow.
No, it's better. It's better.
Yeah, it's
hold the cable.
Something like that, exactly.
You need an assistant?
No, it's fine. Thanks. This is actually the downstream Bianbu stuff, just to kind of as a reference, not. Oh, I think now, whatever it is, it kind of killed. Now, I think the default password is Biambu, and they only have a root account as far as I know. That's basically what you get. Not it is like I said, 6636, and kind of works. And now I have another SD card. Where did I put it? Yeah, so I have another SD card, and I have here U-boot sources, for example. And we can try, for example, this U-boot ITB thing. And in the U-boot sources, I can also make that bigger. You find that documented board SpacemiT banana pie. That's this document that I mentioned, not blah blah blah. And then they basically say burn your fingers. Let's see. Here. So the fourth partition of the SD card. Let's check that. LS block, not. So this is this SD card, and the fourth one is this 2 mega thing. Is the bootloader node. So we can basically DD that U-boot ITB thing to the SDA4. Woohoo! Make sure you don't write your whatever. Let's have a look. We put this SD card in. And this guy. And we reapply power. Woohoo! So you see here it's now running mainline U-boot. Of course, like I said, it doesn't have Ethernet or anything, but it has some driver model drivers. You see, it's basically the serial driver, which, by the way, that was kind of an interesting thing, because, I don't know, Marek is not here, back in the days when we played with PXAs, and it looks like, for who knows how, but this Chinese company, SpacemiT, they actually use UART IP from the PXA. So from Intel, or I mean, who knows how they got that, but that's what they're using, and that's also why it's really easy. In U-boot, the driver is there, it's just the regular 8250 driver with this special whatever PXA register mapping, and that just seems to work, So. But that's more or less it. It doesn't. It has the CPUs and the console, and doesn't do anything else. Okay. Then the next piece would be, I already a little bit prepared it so we don't run out of time. I already put the kernel on that SD card, but now we need a bootloader that can actually boot that node. Otherwise it's kind of not going to work. So we go back to this one, and now we did another bootloader again. Let's see. Banana Pie. Which is maybe, if I have that right, would be this one. Let's see. Micro SD cards are so small, so you can hardly handle them, not? Wait on the nano SD card. Reapply power. Let's see if that does anything. Here you go. Now we're in whatever downstream U-boot again, not? And then I have somewhere some notes. Basically this what I had on the slide, not? I can run that. Rumpel die Stilzen and set the boot args, and then we boot that thing. Woohoo! And we're in this initram FS, and it's running 613-next with all this stuff, not? And like I said, there is this I2C transfer thing that you can play with, not? Ooh. Yeah, I think that doesn't always work.
This address is right? R8 and
Yeah. R, I think, means read. 8 will be 8 bytes, and at will be 80 is the I2C address, and the 1 is the bus, not? I don't know. Right now it...
is that a device on the board?
Yeah, exactly. It's on EEPROM, but I don't know why. It's probably just a demo effect. No?
Do they have I2C to chat? To see if
No, that's the only thing exactly that is available. See. Anyway, that's about it. The status of Upstream on embedded RISC-V stuff. Not. Thank you very much. Any questions?
Hi.
Go ahead. Yeah.
Thank you. That already looks very good. I actually looked at the SPL.
Okay.
There is a binary blob for the DRAM training, and after like 2 weeks of Ghidra, we now have an open source implementation.
Mm-hmm.
Do you want that? Do you want to upstream it?
Yeah, I
What's
guess
in touch?
sooner or later somebody should just upstream it. Yeah? If
I'm
you
looking
have
for
some
somebody.
stuff.
You would need to translate it from Rust to C, but that's trivial code.
Yeah.
We'll get in touch with you.
Okay, thank you very much.
What's in the byte info, the first 80 bytes? What does that contain?
I haven't looked in detail actually,
You
but
just know that it needs it.
yeah, I assume it's just some kind of a header that then points to the other pieces or something, but I haven't in detail looked. I think in downstream they use some Python stuff even to generate it or something. So I think it's not totally closed or anything like that, but the question will be a little bit what do we even really need and how do we want to do it, not in upstream basically. And I think they use the same header on the SD card or in the eMMC or in an OR or something like that. So I think it's just like, I don't know, I know from Toradex the Freescale stuff, not? They also have some kind of a boot, I don't remember how it's called. iMix image or something. No? Okay, go ahead.
Do you have some... I tried Googling it before because I was interested in that board.
Sure.
It's very hard to come by that information, so probably I'm hoping that you know what are the IP vendors of the different peripherals, like networking, eMMC, graphics, and so on. I'm sure they didn't do it on their own, so...
Like I said, on the UART, I know that it's from PXA, but I have not checked on further pieces, yeah. Okay. And I'm not sure how much is known or listed somewhere or documented, but I don't know.
The downstream kernel device tree claims to be that the CanFD controller is compatible with the FlexCan from NXP.
Yeah, okay, the CAN controller, yeah. Mm-hmm.
Yeah, I don't know if they have bought it or got their hands on it, I don't know.
That was also a little bit my question, remember whether they stole that together or they really have an IP license or how they exactly do that. But actually, it's almost convenient if they just stole it, because then you can just use the driver, no? But from a legal point of view, I mean, yeah, it doesn't sound like, I don't know, yeah.
Hello. Have you tried overclocking it? Overclocking. Have you tried it?
Overclocking? No, I haven't tried.
Because the actual CPU was firstly advertised at 1.8, but it usually comes now at 1.6. So I did try, and it works with 1.8.
Yeah.
But I wanted to know if someone did more than that.
I have not tried it, and I also read different in different sources. They talk about different frequencies and stuff, but how it works and whether they, I mean, I know also from like Freescale, they kind of create their chips, and they usually have a way to do that. Not maybe the bootloader or something to then know.
No, it's Linux kernel based.
Yeah, here I don't know whether. Yeah.
Okay.
But I think there is also a second version available. It's called M1, not?
Yes.
And that has also supposedly different frequencies again. But whether it's a different production process or something, I don't know. Yeah.
The various patch set that you've referenced, would you say this is a community effort similar to Santi, or are there actually contacts from, you know, the various vendors involved in at least reviewing the patches, if not sending them upstream?
Yeah, I think there isn't really kind of a community around it yet, I would say. I mean, it's just some patches from, I'm not sure where.
But someone is sending it. So
Yeah.
It's not someone from the vendor, right? So it's.
I don't think so, but I'm not fully sure. Yeah. I think this RAM patch now on the U-boot, for example, maybe that was also only the discussion. Yeah, I really don't know. Yeah. I mean, those people didn't say anything to me, basically, and they don't. The email addresses, whatever, not Gmail, whatever. Okay. If there aren't any questions, yeah, thank you very much.
It's a wrap. Thank you.